Hello, Prospervarians. The best school has come to stay in the city of Calabar. It is called Beryl International School. Take advantage of this opportunity now.
Tell me the best school, Beryl is the best. Tell me the best school.
You're welcome. Alright, you're welcome to physics class. How are you doing? And I hope you got the last class recording. You've done your assignments. Don't worry, I'll check your notes and do the necessary correction and send them back to you. Okay, today we will look at another new topic on the board, which is fluids at rest and in motion. Fluids at rest and in motion. Under this topic, there is something very interesting I want you to note. I will explain that later, but we'll look at, first of all, we'll look at the definition, or let's say, surface tension. I don't know if you've heard of it before. And the application of its effects. That's the first one we'll look at. And then on this topic also we shall also look at capillarity. Capillarity and viscosity. Capillarity and viscosity. Then if time permits, we'll look at similarities and differences between viscosity and friction. We have talked about friction. That was the second term. We dealt with friction and all the forces involved in friction. Now, before I go into details, first of all, when we say fluid at rest and in motion, I told you when we dealt with elasticity, that it was considered elasticity of solids. There's nothing like elasticity of liquid or gas. But today, we're looking at that which will concern liquid and gas, and that's fluids. So when we say fluid, it simply means liquid, could also be in the gaseous state. So fluid at rest and in motion. Now, a typical experiment I would have carried out here, actually I lost sight of it, but I know it's simple enough for you to do at home, is take a bowl, fill it with water, and then get a filter paper. A filter paper is easily absorbed or soaked in water. Get a filter paper, and on top of the filter paper, position either a needle or a razor blade on it, and then carefully drop it on the surface of water in the bowl you prepared. Watch the water to soak the filter paper gradually, and it will soak the filter paper to an extent that the filter paper will go down the bowl. But the razor blade or the needle that you position on the filter paper before it got soaked with water will be floating on the surface of that liquid. That is a typical experiment to demonstrate surface tension. So if we're saying that, then what is surface tension? Surface tension, I think, or you can take them. Surface tension is the force acting on the surface of a liquid is the force acting on the surface of a liquid. Okay? Okay? I said surface tension is the force acting along the surface of a liquid, causing the liquid surface to behave like a stretched elastic skin. Isn't it? To put that definition. This stuff, okay? So I said surface tension is a force. So surface tension is a force acting on the surface of a liquid, causing the liquid surface to behave like a stretched elastic skin. Just like the experiment I told you earlier. Now you may be wondering how come they need to float on the surface, because the surface is behaving like a stretched elastic skin. You can also say it's an external force that acts on every object or material that is positioned on top of the surface of the liquid. So that's surface tension. Okay, let's look at the effects or application of the effect of surface tension. Application. Of effects of surface tension. Application of the effect of surface tension, particularly in waterproof material, right? Waterproof material. Waterproof material such like rain coat, right? Raincoats and what other material? Those materials that are used. So materials that are used for making raincoat, materials used for making raincoats, for umbrellas, and then maybe for building tents. All of these materials used for this purpose were designed in such a way, the fabrics are well designed in such a way that water will not be able to go through it, just like the material I'm putting on, and if you put it inside water, you see water go. But have you ever wondered why an umbrella on a rainy day, the way you carry the umbrella on a rainy day, the rain, drops of rain falls on it, but it does not penetrate to touch you at the inside the umbrella. Such a material has made up of oil films, such that the fabrics are well designed to an extent that it can help to prevent water from wetting the person inside the umbrella. So that's one of typical examples of the application of surface tension. Also, another application of surface tension is maybe you have attempted washing your dishes without soap. What did you notice? While washing the oil from the plates and all that with water only, without soap, it becomes very difficult for those debts to fly away or to be removed with water, just water alone, without soap. Now, but when you apply soap, it will help do what? Break the hold, the effect of surface tension caused by the oil in those dishes you are washing to float out with the water completely, and then making your dishes very clean, your plates clean and well presented for use. That's another effect of surface tension, and you can call it cleaning action of soap and detergent. It's another effect. Cleaning action of soap and detergents. Okay, I just explained this because the dirt will not leave except you are able to apply soap so that it will break the hold or the effect of surface tension that was already formed because of the oily substance that you use the dishes to consume and all that. So that's exactly what happened. Now we go into capillarity and viscosity. Capillarity and viscosity. Okay? I can take this off, right? Capillarity and viscosity is our next subheading. Capillarity and viscosity. Now I'm going to show you a diagram. Watch out this diagram. Okay, look at this diagram you have here. Now before I further demonstrate on this diagram, I want you to